Alright, today we're going to learn about slope fields. Now if you remember that differential equations give us the slope of a function at any point. So here's a differential equation, dy over dx equals negative x over y. So you can plug in numbers for x and y to find the slope at that point. So the first one is 1, 1. So if you plug in 1, 1, you get negative 1 over 1, which is negative 1. So that's over here. The point 1, 1 gives us a negative 1 slope, and that's this one right here. Okay. Now, if you plug in 1, negative 1 into this differential equation, then it comes out positive 1. So 1, negative 1 is here, and then you can see that the slope is positive because it's going up. And it's positive 1, it's about a 45-degree angle. And then if you plug in 2, 1, you get negative 2 over 1, which is negative 2. And so you get this one, which is a little bit steeper. This is a negative 2 slope. If you plug in negative 2, 1, then it comes out positive 2. Negative 2, 1 is here. That's positive 2 slope. A little bit steeper than the positive 1 slope down here. Okay, so that's how slope fields are generated. It's just by plugging in x and y coordinates into the differential equation. Now if you also notice that every point on the y-axis, x equals 0, the slope is equal to 0. So you can see here, this slope is equal to 0, this one, and this one. The tangent line is horizontal at those points. Now that's just for this differential equation. It doesn't mean it's always going to be that way. And also at every point on the x-axis, y equals 0, the slope doesn't exist, or the tangent line is vertical. So x-axis is this one, and then you can see that you have vertical tangent lines here. So these little things can clue you in on what the equation is, if it's not given already. So the graph is a family of semicircles. So it forms semicircles. Okay, now let's look at tips for differential equations and slope fields. If the differential equation dy over dx equals 0, you get horizontal dashes. Those are horizontal tangent lines, like the ones that we just saw. So like this right here. If dy over dx is greater than 0, you get a positive slope. So we just went over those. This is a positive slope, a forward slash. If the differential equation is less than 0, you get a negative slope, backslashes. Some other things over here. If the differential equation does not have a y, then all dashes on the same vertical axis are parallel. So if differential equation has no y, you get all these parallel lines on the vertical axis like this. If the differential equation does not have an x, all dashes on the same horizontal axis are parallel. So you get dashes like this on the horizontal axis that are parallel if there is no x. The differential equation is periodic if dashes look like a periodic function, so like this. So like a sine or a cosine wave. Okay, in this example, we'll describe the slope field. It's kind of hard to see there, but maybe I can zoom in here. And then focus. Okay, well you see that you have some vertical lines here. And then it starts to curve around here. So that's curving like that. So all along this vertical axis, they're curving. And then they also curve right here. And so for step 1, all dashes on vertical axis are parallel. So you see on the vertical axis they're all parallel. That means the differential equation will have no y. Slope is 0 at x equals 0 and x equals 2. Okay, so that's where we saw these curves. If it goes from up to down, it's got to be 0 somewhere. So it's 0 on the line x equals 0. This is the line x equals 0, which is the y-axis. So you got all horizontal tangents here. And then you got all horizontal tangents here. Slope is 0 at those points. The slope is greater than 0 at x is less than 0 and x is greater than 2. So you get all positive slopes here where x is less than 0 and x is greater than 2. So you get all positive slopes after x is greater than 2. The slope is less than 0 at 0. Well, not at 0, but the slope is less than 0 between 2 and 0. So right here, that's what they're talking about, is that you get negative slopes. So all between that area. So now we get to guess the differential equation. So let me zoom out. So it's dy over dx. Now a big clue is that the slope is 0 at x equals 0 and x equals 2. Now if you remember when you factor that, you get an equation like this. Like if x equals 0, then the whole equation is 0. So that's how you know that the slope is 0 at x equals 0. Also at x equals 2. So if you plug in 2 for this, you would get a 0 slope, 0 differential equation. So then you have to see if it satisfies all the other conditions. So if I plug in a number that's less than 0 for x and greater than 2, so if you plug in like a -1, then you would get a slope that's greater than 0. So if you plug in a number like 3, because that's greater than 2. If you plug in a 3, then you would get a positive slope. You get a positive outcome here. And slope is less than 0 between 2 and 0. So if you plug in, say, a 1 for x here, you would get a negative outcome. And that would give you a negative slope. Okay, so this is the correct differential equation for this slope field. Okay, let's look at another example. This one right here. Okay, so it's all dashes on the same horizontal axis are parallel. So all the lines, all the slopes are parallel going this way. Okay, so you can see that there. So that means there's no x. There's no x in the differential equation. Just like the last one had no y in it, this one would have no x. It is a periodic function because it's going in a wave. Only thing is it's going like a wave like vertically. So it could be a sine cosine wave. The slope is equal to 0 at negative pi, 0, and pi. So you can see that there are 0 slopes at 0, negative pi, and pi. And all the slopes are either greater than or equal to negative 1 or less than or equal to 1. Okay, so if you know that, you know it's periodic, so you want to guess maybe sine or cosine. But you know that a sine wave has a 0 slope at y equals negative pi, 0, and pi. So if there's no x, then the equation would have to be dy over dx equals sine y. So if you plug in negative pi, 0 over pi, you would get a 0 slope for this equation.